Hey everyone, and welcome! Today, we're going to tackle fractions and decimals, and I promise, by the end of this, you are going to have all the key methods you need to solve these problems with total confidence, whether it's for a test or just for real life. So think about it for a second. You're splitting a pizza with friends, you get your test score back, you're trying to follow a recipe. What's the one thing that connects all of these situations? You got it, it's fractions and decimals. They are literally everywhere. And the best part is, they're not as complicated as they seem. They just follow a few simple, logical rules. So today, we're going to walk through them together, step by step, so you feel completely in control. Okay, here's our game plan. We'll kick things off with a quick fraction review. Then we'll cover adding, subtracting, multiplying, and dividing. And we'll wrap it all up by decoding decimals. Let's jump right in. First things first, let's just do a super quick refresh on the three main types of fractions. Seriously, getting these down is the foundation for everything else we're going to do. All right, so a proper fraction, like 3/5, is always less than one whole thing. Just picture a pizza cut into 5 slices. If you eat 3 of them, you've eaten a proper fraction of that pizza. Simple as that. Now, an improper fraction, like 7/4, is when you have more than one whole. Think of it this way. A pizza is supposed to have 4 slices, right? But what if you have 7 slices? Well, that means you've got one whole pizza and a few extra slices left over. And that leads us perfectly into mixed fractions. A mixed fraction is just a much friendlier way of writing that improper fraction. So instead of saying 7/4, we can just say 1 3/4. It clearly shows you the full whole pizza and the fractional part you have left. Okay, now that we're all on the same page, let's get into adding and subtracting. And honestly, there's one big rule here that, once you get it, makes everything else just click into place. So this is the big question, isn't it? You can't just add 1/2 and 1/4 because the pieces are totally different sizes. It's like adding apples and oranges. So what's the secret to making them play nicely together? Here it is, the common denominator method. This is a huge tip for any test. Before you can add or subtract, the pieces have to be the same size. That means we need a common denominator. We find the smallest number both denominators fit into, that's the least common multiple. We convert our fractions, and then it's easy. We just add or subtract the tops. Let's put this method to the test with a real problem you'd see in a textbook. Samir is buying fruit, but the weights are different fractions. How do we figure out the total? Okay, first step is to make our lives easier. Let's convert these mixed numbers into improper fractions. For the apples, it's 3 times 2 plus 1. That gives us 7/2. For the oranges, 4 times 4 plus 3. That's 19/4. Much better. And now we just follow our 4 steps. So the least common multiple of 2 and 4, well, that's 4. So we need to change 7/2 into something over 4. That's 14/4. Great. Now the denominators match. We can just add the tops. 14 plus 19 is 33. Our answer is 33/4. And for the final step, let's turn that improper fraction back into a nice, clean, mixed number. 33 divided by 4 is 8, with a little left over, 1 to be exact. So the total is 8 1/4 kilograms of fruit. See? That 4-step method works like a charm. Let's switch gears and talk about multiplication. And I've got some great news for you. This is actually way easier than adding. You can completely forget about common denominators here. Okay, here is a top-tier test tip. Whenever you're reading a word problem and you see the little word of between a fraction and a number, like 1/2 of the students, I want your brain to immediately just think multiply. It's a fantastic shortcut. And the rule itself? It could not be easier. You just multiply straight across. Multiply the top numbers together, then multiply the bottom numbers together. That's it. No common denominators, no extra steps. Just multiply across. All right, so what about division? I know this is where some people get a little nervous, but there is an awesome trick that basically turns a tricky division problem into something we already know how to do. So first, let me introduce you to our secret weapon for division, the reciprocal. It sounds fancy, but all it means is you flip the fraction upside down. So the reciprocal of 2/7 is just 7/2. This little flip is the entire key to dividing fractions. And here is the magic trick. Just remember these 3 little words: keep, change, flip. To divide fractions, you keep the first fraction exactly the same. You change the division sign to a multiplication sign, and you flip the second fraction to its reciprocal. And just like that, you've turned a division problem into a super easy multiplication problem. Okay, we're on the home stretch. Our final section is all about decimals. Now, they might look a little different, but you're about to see we use a lot of the same logic, especially when it comes to multiplying and dividing. When you multiply decimals, just follow this simple three-step system. Step 1, pretend the decimals aren't even there, and just multiply the numbers. Step 2, go back and count the total number of decimal places in your original numbers. And finally, step 3, put the decimal point back into your answer so it has that same number of decimal places. It's a foolproof system. And for division, the whole game is to make the number you're dividing by, the divisor, a whole number. You just shift the decimal point all the way to the right. But here's the crucial rule. However many spots you move it in the divisor, you have to move it the exact same number of spots in the dividend. Once you've done that, it's just a normal division problem. So there you have it. You see? Fractions and decimals aren't just a bunch of random, confusing rules. They're part of a clear, logical system, and now you have the tools to solve them. So the only question left is, what real-world puzzle are you going to solve first?